So in this problem, we're going to be trying to find the length of an arc given that the radius is 12.64 inches. So that's referring to this part, 12.64. And I'll write just right here, r equals 12.64. And the angle, the central angle, is 150 degrees. So 150 degrees would be maybe about this much. 150, and I'll just write right here, the angle is 150 degrees. So the question is really asking us for the length, the arc length of this portion. So there are two ways to solve this problem. One way would be to use this formula of 2 pi r, which is the circumference of a circle, but you multiply it by the angle over the whole angle of a circle, which is 360 degrees. So if you use this formula, it would be 2 pi times r, which is 12.64. You multiply it by the angle of the arc, which is 150 degrees, over the total of the circle, which is 360. And if you do that, you could multiply the 2 and the 360. They can 2 over 1, 2 and the 360. You can simplify both because they both can be divided by 2. 2 divided by 2 is 1. 360 divided by 2 is 180. So you would get, I'll write the 12.64 times the 150 degrees over 180 degrees simplifies to, you can divide both by 30. 150 divided by 30 gives you 5. 180 divided by 30 gives you 6. So you get 5 over 6, and don't forget the pi. So basically it becomes 12.64 times 5 over 6 pi, and if you do that math, you get an answer of 33.0914 and some numbers after that. But because the question is saying to round to nearest hundredth, the hundredth would be this 9, but you look to the one to the right of that, the 1, which is less than 5. So if you round to nearest hundredth, it's going to be 33.09 inches. Now that's the one way to solve it. Another way would be to use something that we call the arc length formula, which is S equals r theta. So this is a really handy equation to know because as long as you know the radius, which we do, it's 12.64, and if we know the angle in radians, you can solve for S, which is referring to the arc length. Now, this is a little tricky because we're not given the angle in radians, we're given to in degrees. But if we know how to convert 150 degrees to radians, we can use this formula. So first, 150 degrees, what is that in radians? That's the question. So again, if you know that pi is equal to 180 degrees, you want to ask yourself, okay, what is 150 in radians? Well, if I multiply 180 by 5 over 6, 180 times 5 over 6 gives me 150 degrees, which is what I want. And since I multiplied this side, the right side, by 5 over 6, I'm going to multiply the left side by 5 over 6. And 5 over 6 times pi is just 5 pi over 6, 5 over 6 pi, same thing. So there I have my angle, which is given to me as 150 degrees. I found out that it's 5 over 6 pi. So that's good. That's what my theta is. So I'm going to use 5 over 6 pi into my arc length formula. So S is going to be equal to R, which is 12.64, and I'm going to multiply it by theta, which is again 5/6 pi. And if you notice, this is exactly the same as the same expression we got when we used the other formula. So it really becomes the same thing, 12.64 times 5/6 pi, which equals 33.094914 and so on. But if you round to the nearest hundredth, you get 33.09 inches. So it's up to you whichever formula you want to use. If you're more comfortable with degrees, then use this one. But if you know how to convert from degrees to radians, it's probably more preferable to use the arc length formula, S equals R theta. So the answer to this question is going to be 33.09 inches. And that's the answer.